I'm going to go kind of quick. I have a lot of content, but the slides are going to be online afterwards. I'm happy to take questions. I'll come back to anything you'll need me to come back to. So this talk is called NoSQL and SQL, Getting to Have It All. My subtitle to this is My Guide to a Totally Fun, Crazy Scalable Relational Database. So first, I want to introduce myself briefly. I started hacking Rails almost coincidentally back in 2005. I went back and looked at the email, and when I did it was Rails 0.13, which was 80 kilobytes of total awesomeness. Rails 4.1 is 17 times bigger. Recently I've been doing sort of architecture and code and operations and management. I was at Script for a while. It was a top 100 website in the world. It was one of the biggest Rails sites out there. Then I was over at Couchsurfing that had about 7 million users. Now I'm at SwiftType. SwiftType is site search in a box as a service. So if you need stuff on your site searched, you may be tempted to install Solr or Elasticsearch, which actually is a lot harder than you think it is. You can come to SwiftType and we'll set it up for you. We're selling, we're also hiring. So that's my plug. Done with that. My real interests are Rails at large. Like, how do you do Rails in the context of lots of developers, lots of code base, high complexity, not necessarily scaling to many users, although that's often part of it. The techniques I'm going to show you here tonight have been proven, and like we've used them at several different companies at like 100 million rows or more. So this is not experimental ideas that, hey, may or may not work. There's a great place for those. This is real stuff. So who's this talk for? This is for basically anybody who's messing around with a core data layer in your application. Anybody who touches it in any way. This is core business data. Your app can be just about anything. So traditional, single, HTML-driven multi-page apps, a single-page JavaScript app, your native mobile app that uses Rails APIs. All of this touches core data, so this is applicable to any of that. This also works for both brand new applications that are totally greenfield or like grizzled old giant Rails code bases. I've seen a few of those. So I'm going to talk about core business data. That's what this is applicable to. So what does that mean? Core business data is things like users, accounts, permissions. Everybody has stuff like this. It's also stuff like email preferences, A/B test assignments, users who block other users. It's anything you really can't run your application without. That's my definition of core business data. It is not things like web logs, behavioral analysis data, audit trails. That stuff is stuff that's typically done offline. That's a completely different talk. It's also not like large objects. So if you're dealing with like, giant videos in a database or graph data, like you're mirroring Facebook's social graph, don't listen to me tonight. It's going to go badly. So where do we put this stuff? Traditionally, we have two choices. You can choose a relational database or a NoSQL database. That's today, I say. Traditionally, 5 years ago, it was just relational databases. So if you choose a relational database, you get a lot of stuff for free that people often don't think about. You get ACID transactions. You get a lot of operational flexibility. So with relational databases, you can have slaves and streaming backups and all kinds of stuff that we kind of take for granted. There's a really robust ecosystem because there's really only a few players in the relational database world. You can find consultants and books and training and what have you. You also typically have really efficient storage. That is, in terms of your actual data, the storage on disk and more importantly in memory is quite compact. The reason people have started looking away from relational databases, I think, for core business data is that you also have a lot to give up. Typically you have limited data types. You don't sometimes you want to store like a hash of arrays, of hashes of arrays, or something crazy like that. You just can't do that in any straightforward manner in a relational database directly. You have like strings and booleans and ints and stuff like that. You have a heavyweight schema. You've got to run migrations. They're a big deal. You've got to be careful. And you might have some scalability concerns, like is this database going to support what I need it to support? If you move over to NoSQL, I would argue a lot of people do this because it fixes a lot of those concerns. You have flexible data types, so you can store any kind of crazy data structure you want. You have no migrations typically, which is awesome. And hopefully you have better scaling. That's a lot of the promise of NoSQL. The thing is that you actually give up a lot of this other stuff too. Many NoSQL data stores don't support transactions at all, which I would argue is a huge deal. Deployments and support, like the NoSQL community is currently really fragmented into a lot of different pieces, and there's not a couple dominant players like there are in the relational database world. So no matter which one you pick, you may not be able to find a community as big as on the relational database side. That's a big deal. There's also considerably less efficient storage. A lot of this stuff is done in JSON or similar data types, which have more overhead. So tonight, what I'm going to show you is, I'm going to split the talk into 3 parts. The first part is going to show you how to deal with this problem of limited data types and a heavyweight schema in a relational database, and how to improve its sort of how easily you can develop on top of it in that way. Second thing I'm going to discuss is efficient storage. It's actually how to make your relational database storage even more efficient, which, when you're using it as a developer, is a big win. And then the final one is scalability concerns. I'm going to address how do you scale a relational database in a way that you know is going to work. So in order to do this, I'm going to introduce a users table. I'll come back to this several times. It's not like you need to memorize it. This is sort of an amalgam of users tables I've seen over the years. This is not, there's no one company that has this users table. I put a bunch of different stuff into it that's pretty typical. My main point is this is not the like Rails 101 book 5-column user table that's really nice and simple. This is more like the kind of stuff I think people actually have in production. Again, I'll come back to it. So the first thing I'm going to talk about is storing JSON in your relational database. And especially a few years ago, this is like, oh my, really? Well, this used to be heresy, and part of my point tonight is there's not actually a reason not to store some data this way if you're careful and you have the right tools. So what does being careful mean? Being careful means you only ever store data in JSON format in your relational database that you won't ever need to query on, because generally you can't do it. And I know the Postgres fans out there are like, oh yeah, you can in Postgres, and that's really cool, but there's still a lot of limitations on it. In general, I would prefer not to have to query on data in the JSON field. Also, and this is, I think, a point that's less obvious, you only want to put data in JSON that you need for one row at a time. So taking our users table, say we're going to show users to other users. This is a really common thing for a lot of systems. I'm going to show you a page of 35 other users and you want to talk to them or whatever. If you're going to put, say, pictures on the screen, don't store the user's profile URL in this JSON blob, because then when you display those 35 users, you've got to pull this JSON data out and serialize it for all of them at once. That's pretty expensive. The other big deal is don't ever store defaults in a JSON blob. This is easy to do. Oh, there's a bunch of default values. I'll save them to the database. You can end up with a table that has like 100 million rows of JSON blobs that have the exact same data in it over and over and over again. That's a nightmare. Anybody who worked with me at a particular company that I won't name may have experienced this problem. It's not fun. So let's go back to our users table. Given those criteria, what are we going to use for a JSON store? There's some stuff in here that's pretty obvious, like locale of the user. What language do they want to see our site in? We only have to look at that for the currently logged in user. We're probably not ever going to query on that. If we do, it's not that big a deal. Like, it's usually not a mission critical query. So that's a good candidate. A couple other things that are probably less obvious are we have some OAuth tokens in our database and maybe a Stripe token for customer records. Again, we only deal with that with the currently logged in user. We're never going to select those out in bulk or query on them. The final one that I think is actually, once I realized is sort of staring everybody right in the face, is your password hash. That's a great candidate. You only load the password for the currently logged in user. You touch it rarely. You never query on it because it's just this gibberish anyway. So all 4 of those things can go in our JSON data store. So how do you do this? There's an obvious way to do this. And I know this might be hard to do in the back. I apologize. I'll go through it real quickly. You basically take your users table. You add a text column that's going to be your JSON store. You migrate the data, which I left out of here. And you drop the old columns. So now everything's in the JSON store, right? And there's this tool, Active Record Store, that comes with Rails these days that lets you basically make those act-like attributes on your Active Record model, and it'll serialize and deserialize the JSON really easily. So, ta-da, we're done. Except, not quite. So you look and see what you've really done if you've done this. We've removed 5 standard columns. We've added 1 JSON store with its contents. And we've added 85 bytes of overhead to every single row, which doesn't sound like a lot until you have 100 million users, and then it's a big, big deal. And so most of those bytes are just the column names of data in the JSON store. It's just like Facebook OAuth token is repeated 100 million times. This is not a win. This is loaded every single time you retrieve users for any reason. Let's try this again. There's a gem out there that I published called Flex Columns. And here's how we do it with that. We're going to create a separate table for this JSON store. It's called user details. It's got 2 columns, user ID and the JSON block. It's one-to-one with the users table. We're going to add the data there, and we're going to remove it from the users table. We're going to drop those columns entirely. We have this flex columns gem. And it has a little DSL for defining the language for these columns. We'll do a one-to-one with the user, and down here we're going to say include flex columns from. And what this does is it makes the attributes in this JSON hash that's actually living in another table show up directly on the user as if they were attributes of that user directly. You still can't query on them, but you don't have to change any of the rest of your code. Nothing else knows that those columns suddenly are on the user model directly. And at this point, we're only going to have to load that JSON store from disk and ship it across the network and deserialize it for those few attributes that we only ever use for like the currently logged in user. This is actually a big win. There's one more thing we're going to do. This gem has quite a few features. One of them is that we can define the names of the columns to be used in the JSON store separately from how they're used in the application. We're going to say, hey, in the application, I'm going to call this thing password hash. In the database, please call it PW. For the locale, call it L, and so forth. This is the kind of thing that kind of seems dumb, except that, again, when you multiply this by 100 million rows, you've actually reduced the overhead a great deal. It makes a big difference in your database. One more set of stuff that FlexColumn does, there's a lot of features in there, but just to mention a few of them, it also does transparent Gzip compression. If you store things like HTML in your database, this can make a huge difference in how big your actual rows are. It's got full validation support. It even supports these kind of types that are very much like active record traditional database types. It'll remove no longer used fields from the JSON, so if you remove a field, it will go clean up the stuff as you save back out these JSON hashes later. It also supports Rails 3.0 through 4.1, any remotely recent version of Ruby, and JRuby, MySQL, Postgres, SQLite, kind of like an industrial strength version of active record store. So that's the first technique I have to make your relational database a little bit more like a NoSQL database and be able to use it much more flexibly, because now you can store things like hashes and arrays of hashes in there and do whatever you want. Second technique I'm going to call low cardinality tables. This is also bit fields in your database, but done right, for anybody who's done C and bit fields. So what's cardinality? Cardinality is the number of distinct values that a column holds. So a high cardinality column is something like username or email address or first name. Username and email address are probably unique. Every user is different. First name, it's not unique, but there's a lot of different first names out there, right? Low cardinality is stuff like deleted, so that's a Boolean, it's just 2 values. Gender, let's take Facebook's gender thing, which I think is great. They have 27 different values for gender, but that's still pretty low cardinality compared to like 100 million users. There's also like your admin level, maybe you have 4 admin levels. Those are all low cardinality columns. And one thing you can look at is we're almost always storing those as full columns. Why are we using an entire column for like a 1-bit flag so that we can store in like 4 bits? Coming back to our users table, I think this is actually pretty typical. If you look at which columns in our users table are low cardinality, there's actually quite a lot of them. In this case, it's almost a third of the table. In my experience, this is pretty typical. You have lots and lots of flags in your users because they behave in many different ways. I'm not going to go through all of them right here, but suffice it to say, I think it's pretty straightforward. These are all of the columns that are like flags or enums in some way. What can we do with this? With this low card tables gem, here's what we're going to do. We're going to create a new table called user statuses. I tend to use the word status for this. You can call it anything you want. In the migration, we say low card goes to true. This creates a table with exactly those columns that we're going to pull off the users table. We're going to create a model for it, declare it as a low card table. We're going to tell the user class that it has this low card table. So what has this done? This is not doing what you may think it's doing. This actually, I want to make one more point. When we pull this out, the other thing that we're going to do is take things like gender and forum level, and instead of storing them as integers, we're going to store them as actual strings. It's really annoying to be like, oh, you know, forum level is 7, what does that mean? Or gender value is 17, I have no idea what that means. And the number of times I've actually had to go into a database and like select out first names in the gender value to figure out which one means male and which means female is kind of ridiculous. So I'm going to store this stuff as strings. Here's what's actually happening. This low card table gem is going to create one row in the low card table for each unique combination of flags from the users table automatically. So as you store users, it's going to populate this table automatically by saying, hey, is there the combination I need in there already? If so, use it. Otherwise, go create it. And then down here in the users table, we're just having pointers back to this. So you look at like the first row, you say, okay, user ID 1 has user status ID 3. That way we know that Mary Schultz is female, not anonymous, a beginner, has a verified email, and we send a newsletter to her. Because this is all done on demand, too, any combinations of data that you don't actually have, that theoretically could exist, but you don't actually have, never end up in this table. So we don't have, like say we never send a newsletter to non-verified email addresses. Sounds reasonable? There are no combinations of false and true in here. So we create just the rows we need. It's kind of as efficient as you can possibly get. This is sort of describing what I just said in text. We're generating these rows on demand. This is a big deal. So what we do at runtime is actually cache this entire table in memory. This only has a few hundred rows. Now Rails is going to operate on this thing incredibly quickly. And in production stable state, you get 0 extra queries to this table ever, because you pretty rapidly end up with every combination you're ever going to have in there, and it's all sitting in memory. And it all does, there's lots of stuff in there to handle database locking, so that multiple processes try to create the same row at the same time, you don't run into problems, it all just kind of works. It's also way more straightforward from a SQL prompt. If you're sitting in actual MySQL console or Postgres console, trying to figure out what's going on with this is way better than if you actually try to implement bit fields in your database where you have this giant integer that you're trying to break down into like these 4 bits and these 2 bits and stuff like that. Also, the last point I'll make, indexes on Boolean fields typically are useless. Your database won't use an index unless it thinks it's going to narrow it down to a very small percentage of rows, because a full table scan is cheaper. That's still true if you're going to look for like all non-deleted users in your database. There's nothing that's going to help there. But if you're looking for particular combinations, like I want deleted anonymous users who are still getting the email for some reason, the index may actually be able to help here, and that's pretty great. So, how does this look from Rails? The short version is it all works exactly like you'd expect. It acts exactly like those are real columns from the users table. You can use where clauses, you can ask questions of it, you can assign gender, you can do validations, you can do default scopes, you can do class level scopes, you can put validations on the status table instead, you can kind of mix it up wherever you want. A few last pieces of this. There's also full bulk support. I've often had the problem of like, I need to import users in batches of 100,000. There are APIs that let you sort of collect those users and very efficiently in 1 or 2 queries it will find and then create all the values in the load card table it needs to handle. There's APIs for partial queries, there's active support notifications if you want to watch what's happening with this. It also supports every recent version of Rails and some not so recent versions, Ruby and JRuby, again, MySQL, Postgres, SQLite. Both these gems actually also work with things like Oracle and SQL Server. I just don't actually have private instances of Oracle and SQL Server at like, I don't know how many thousands of dollars a pop to test against. Nor is there a lot of demand for that. So the last piece I'm going to show is how do you put all this together? How do we synthesize this? So way back when, Rails only supported 1 database. But we know that's not true anymore, right? It's been a long time since that. There's no reason to keep everything in 1 database anymore. I'm actually kind of surprised at how many people still do this. I'm going to introduce you to a gem called DB Charmer. This is not written by me. This is written by a guy named Alexei Kovarin, who's kind of the most amazing ops person I've ever worked with. I've worked with him in 2 different companies. You can't have him. He's ours. Stay away. So what do models look like with DB Charmer? DB Charmer lets you say, on any Rails model, okay, DB magic is the keyword for it. Here's the connection. This ends up being just a hash in database.yaml that says where is the user's master database, where does it live? Populate it however you want. Now, queries for any user's object will automatically go to that database. What's really cool though is you can also define slaves for it. If you have some MySQL slaves or Postgres slaves and say this is a re-replica of that, it will automatically route all queries round robin among those slaves. Unless you're like in a transaction and then automatically knows you're in a transaction, you better talk to the master. It's also got a ton of really cool syntax, like in a good way, that lets you route queries however you want. So you can create scopes and embed, you can say, okay, this scope is always using the master, you can remap databases, you can do all kinds of cool stuff. I have a few, that's basically what I just said. The last point I'll make here is DB Charmer has processed, I kind of did the math, hundreds of billions of queries without a problem. All the script was built on DB Charmer. I mean, this is a website that's typically doing 1,000 queries a second plus all the time. So this is a gem. And to me, I need something I can trust to build a business on top of. This is something I can actually trust. I think Alexei's not always, he's not always as good at like, promoting his stuff, so I kind of want to promote this for him. It's pretty solid. Let's talk a little bit about how we allocate these databases. So now we have this flexibility to put models wherever we want. What do we do with that? Here's what we're going to do. In production, our users people, we're going to live on a server that has lots of RAM. Enough RAM, in fact, that the entire users table and all its indexes just get cached in RAM persistently. This means it's going to serve straight out of RAM. It never needs to touch the disk except for writes. This is really, really fast. This is how you get thousands of queries per second without a problem. And as it turns out, using these tools, one thing we've done is we've broken apart our users table into enough pieces that, I did the math, that sample users table, you can rent a server from Amazon for $24 a month. They can cache 180 million users in its memory using one of their high memory instances. So using these tools, you can end up with a server that's really cheap that can scale to a huge number of users. Our details, this is our JSON block. This is going to go to a server that doesn't need to have that much RAM because it's going to hit disk every time we access it, but that's okay because we're only accessing it for the currently logged in user. It's a one-to-one kind of key value store sort of thing. That's not a problem at all. And then this low cardinality table that we have, this thing can go anywhere because you're basically never ever querying it. In fact, your typical query pattern is going to be when you deploy and restart Rails instances, they will hit this once to load stuff into memory, and then that's it. That's our production deployment, and so for each major table in the system, you would kind of run something like this, except that you really only need to separate the production databases over here. These can stack on top of each other. When you're just starting out, you don't want to buy a ton of infrastructure. You want to do something like this. So you can stack these JSON blobs on the same server. You can throw, again, all the low cardinality tables in just one place. And what I would actually do is buy a single server and create different databases within one server instance. So you have one MySQL D and one Postgres daemon, but then you've got multiple databases within it. This makes sure that you're not joining between instances unnecessarily. It will trap all of those errors right off the bat, but you're not actually spending any more time on hardware management than you need to. So I'm going to come back and wrap up this topic. So why do I care? Why am I giving this talk? Coming back to this slide. Here's my fundamental thesis. I've watched people pick out data stores for their applications. My personal opinion is that losing this stuff is way more painful than you realize. You come in and you're like, okay, no big deal, I get it has a lot of scalability features, that's awesome. Transactions in particular can be a very painful thing to lose. Deployments and support, all of this stuff, it really adds up. I'm not saying don't use a NoSQL database, I'm saying be really careful before you do that and really know what you're getting into. If your core, if you're building a business and part of the core innovation of your business is dealing with vast amounts of data, by all means, a relational database may be a terrible idea for you. But I think a lot of people are building something that hey, our core innovation is not in the data storage itself, it's in something else that we're doing. And I think giving this stuff up can be pretty painful. The tools I think I've shown here tonight can really help you out. I'm not saying to fix every problem in the world, I'm pretty realistic that way, but really help out with a lot of this stuff over here and make relational databases way easier to use and a lot more fun to use as a developer. So, that's the end of my talk. Appreciate it.